Hello, everyone, and welcome to my channel. Today, we are going to tackle a fascinating problem from LeetCode called word pattern. This problem tests your skills in pattern matching and data structure manipulation. And by the end of this video, you will have a solid understanding of how to solve it. So without further ado, let's dive right in. Let's first understand the problem. We are given a pattern, which is a sequence of characters, and a string S containing words separated by spaces. Our goal is to determine if there is a one-to-one correspondence between the letters in the pattern and the words in S. For example, if the pattern is ABBA, if the pattern is ABBA, then the string is dog, cat, cat, dog. We should return true because A corresponds to dog and B corresponds to cat. Is enough, right? Now let's dissect the code step by step to see how it accomplishes this. We start by defining a class solution that contains our solution function word pattern. And this is a good practice to encapsulate our code. And inside the word pattern function, here we split the input string S into a list of words using s.split. This helps us compare the number of words in S with the number of characters in the pattern. Then we use set pattern to get the unique characters in the pattern and set S to get the unique words in S. We compare the length of these sets to ensure that the number of unique characters in the pattern matches the number of unique words in S. Next, then we use zip pattern S to pair each character in the pattern with its corresponding word. Zip function is a built-in Python function that's incredibly useful when you want to pair elements from multiple sequences together. Think of it as a zipper, quite literally, right? This is how it works. So zip function takes two or more iterables as input, and it pairs up elements from each iterable, creating tuples. Let's illustrate this with an example. Suppose we have two tuples, A and B, like this. Now we want to pair up the corresponding names from A and B. This is where zip comes in handy. We create a zip object, which is essentially an iterator of tuples. And it pairs the first item from A. It pairs the first item from A with the first item from B, the second item from A with the second item from B, and so on. Here's how you can use zip to accomplish this. At this point, X is a zip object containing these pairs. Now you might wonder how to display these pairs in a readable format. That's where the tuple function comes into play. You can use it to convert the zip object into a tuple. And when we run this code, the result is a tuple of tuples. As you can see here, each inner tuple represents a pair of corresponding elements from A and B. In this example, we have paired John with Jenny, and Charles with Christy, and Mike with Monica. The zip function is a fantastic tool for working with multiple sequences in Python. It simplifies the process of pairing elements, making your code cleaner and more efficient. Okay, I hope you found this explanation helpful. Please feel free to explore zip further. and use it in your Python projects. Now, let's get back to our LeetCode code. Here, we create a set of these pairs using set, zip, pattern, s. And we check if the length of this set and the pattern are equal. This ensures that there's a one-to-one mapping between characters and words. Finally, we compare the length of the pattern and s to make sure they have the same length, which is a necessary condition for a bijection. Now, let's analyze the time and space complexities of this solution. The set operations and zip operations both have a time complexity of big O of n, where n is the length of the pattern or string. In the solution, we perform 3 set operations, one for the pattern, one for the split string, and one for the zip result, all of which are big O of n. Therefore, the overall time complexity is big O of n. As of for space complexity, it's also big O of n. Here's why. Creating sets based on the pattern and the split string s requires additional space. In the worst case, when all characters or words are unique, the space complexity for creating these sets is big O of n. And creating the zip object and then converting it to a set also requires additional space. In the worst case, when all characters in the pattern are distinct from all words in S, this would also be the big O of n. As you can see, folks, this is an efficient and elegant solution for the given problem constraints, leveraging sets and zip to perform the necessary comparisons. I hope you found this tutorial helpful. If you did, please like and subscribe for more LeetCode tutorials. If you have any questions or suggestions, please leave them in the comments below. I hope you will visit my channel often, and please feel free to share it with any friends you think would benefit from the content. Let's keep pushing forward together on our journey of learning Python and algorithms. Happy coding, and thanks for watching. Goodbye.